Here we have another interesting problem in complex analysis. If the modulus of the function f to z, which is a complex valued function, is bounded by this quantity here, z is r times e to the power of I theta, k in them are constants, we need to prove that the limit of this integral as r goes to infinity is equal to 0. Gamma here, capital gamma, is the semicircular arc of radius r. So we start to write the proof. We take the modulus of the integral over gamma over the semicircular arc f of z dz. We apply triangle type inequality for this integral. So we have the integral over gamma of the modulus of f of z dz. Now we can split the modulus inside the integral, and here we can bound it. We can bound this by m divided by r to the power of k times pi times r, which is the length of the arc. This is the length of the arc, and this bound is obtained by this bound here, that the modulus of f of z is bounded by this quantity. How can we write this? We can write this as m capital M times pi divided by r to the power of k minus 1, where k minus 1 is greater than 0, k is greater than 1. So the modulus of the integral over gamma f of z dz is bounded by this quantity here at the right hand side. Of course, this can be written as 0. This is the modulus is greater or equal to 0. We can write it like this, and the upper bound is m pi divided by r to the power of k minus 1. Now we take the limit as r grows to infinity. We take the limit of this, and here at the upper bound the r grows to infinity, so this one goes to 0, and we can write that the limit as r grows to infinity of the absolute value, the modulus gamma, the integral over gamma f of z dz, and the upper bound is 0. So from here we deduce that this integral, as the radius grows to infinity, this is equal to 0, and consequently we obtain the desired result. And the proof is completed.